Good afternoon, ladies and gentlemen of Precalculus. Good to have everybody here today. Well, not everybody, but they'll be back, and I hope they'll be watching what we do. Maybe. All right. So exercise, we left it here yesterday, exercise 11 and 12. Determine the formula for exponential function whose values are given in the table below. And if you notice that 11 and 12 have the same table associated with it. So you have like an f of x column. You have inputs the same. You have an f of x column and a g of x column, which would be problem 12, g of x. So determine a formula for exponential function whose values are given in the table below. So we're talking initially about this piece here, right? So do you have any idea about that? What an exponential function would be from those values?
6 to the x.
So 6 to the power of x, okay. Now you see what we're...
No, it'd be
3 to the power of x.
No, it'd be 3/4 to the power of x, right?
Okay, let me show you.
Negative 3 to the power of x.
So what happens is Will is he's really thinking. He's doing the exploratory thought for the whole class. I hope you all the rest of you are thinking too.
Yeah.
Let's go ahead and unbundle. Remember, we have the anatomy of an exponential function, which is y equals a times b to the power of x. Remember that?
Yep.
Remember what those pieces are?
B is base, A is not base.
X is
And
variable.
Base, and a is called our initial value. And here, x is going to be our independent variable. And y is going to be our dependent variable. Say dependent variable. Okay, what would be another synonym for initial value when it talks in terms of the graph?
Y-intercept.
It'd be the y-intercept.
Caleb.
Sorry.
Okay, what would be the y-intercept in this thing here?
3/2.
Yeah, so here's our y-intercept, right here. So that's going to be in place of our a. Okay, next we're going to. So next, we're going to put our base here. What is our base going to be?
3. What's the base? I think it's 3.
Okay, your base is the answer to the question. What number do you multiply? Now these are all 1 apart. Do you see that?
Yep.
So base is the answer to the question. What number do you multiply by this number to get this number?
1/2.
And then you check and make sure all these others have a similar type of relationship, right? 3 times 1/2 equals 3 over 2. So what it is, when we do that, we identify our base. And now we have to the power of x. And so that is our answer. Okay? Now what I want to do is I want to choose somebody for problem 12. And I have our wheel here.
Look at that.
We call it as we will.
It's gonna be Kaylee.
Yay! Yay!
Woo,
We
go
did it.
Kaylee.
Okay.
Close
I have
enough.
Kaylee here. I think it's gonna be pretty much.
So it's 12 times 3. See, I told you there's 3 in the next. So put it on.
Like that. Okay, what you're looking for?
To get from 4 to 12, you multiply 4 by 3 to get 12, and then 3 by 12, you get 36. And keep going.
But look at this, we're going this direction here. So you got, what's what number you multiply by that to get that?
Minus, so it's a third?
So it's going to be 1/3, okay?
Yeah. Okay. Oh,
And we get to geometric sequences here later this semester. We're going to delve more into that.
I got a little confused.
I want to tell you that this number 11, this is a very famous type of exponential function. It's called that happened in science. What kind of equation is this?
Decay?
It's exponential decay. It's the half-life formula.
Yeah.
That's what I was looking for.
Half-life, yeah. So we're going to do that later, maybe not tomorrow, but early next week maybe. Okay, good. All right, so the next thing we have, I'll pick up your paper and we'll go to the next one.
I get 2 stars.
Yeah.
Yeah, I do. Yeah, I do. I hope it was close to the class.
Here.
So how'd you get a refresh date on that?
Okay, so what
Make
happened
sure
was
it's
I wore a
fine.
mask in there,
It's
and then both
See,
both
one
put
that
on
says it will
masks.
help.
What?
And they took it off.
He did.
So I could try not to.
Yeah, oh, being sarcastic.
Well, I never noticed you.
Huh? What is that? What? Come on, Will, just say it. We're all girls here. Yeah.
What about Angel and I?
Yes.
We figured about it.
All right, good.
Oh, okay. You're right.
Will, turn around.
Okay,
Huh? If you can, just prove that, then you can tell us.
It's easy.
Didn't say I would.
Doesn't mean you should. Do it. Prove it, Will.
all right.
Well, that's your driver's license.
You can just lie on a driver's license, Kayla.
Yeah.
Anyways.
I guess I don't got
One
it.
was 6'3.5", and they say, sure.
Okay,
Yeah, you're 6'3".
here we have our next set, and this is, again, preliminary and necessary for where we're going today, working with our exponential functions.
I've already done the first couple
Goes
ones.
to
All right,
1.5. Oh, yeah.
so how do you convert this to a decimal?
So what we do is we just move the decimal over 2 places.
So we get 0.15, right?
Yeah, I'll do the next one.
You want to do the next one?
I want to do the next one as a little.
Oh yeah, just spin the wheel. If you're arguing over, I'll do the next, spin the wheel.
4%.
Next one.
What I need to.
It'll be Jana.
Do it down the bottom. You smooth it over 2 places. Left is the right.
All right, Jane, what'd you get for this one?
4%.
So, it was 4%. So what happens is that a percentage is just a different form of an exponent, essentially. Okay, here. Next, this one here. Show how to increase 23 by 7% using a single multiplication.
So you can do 23 times 0.07.
Nope.
I don't know how to do it then.
23 times 1.07.
What is 1.07?
107% of 23.
Huh?
That's how you do it. If you multiply it by a fraction of
Just
a decimal.
multiply it and add it.
Yeah,
7% and then
I
add it all.
don't know what you're doing.
you could do that.
Oh,
Where
that's-
did the 1 come from?
And if you've listened to Will, he actually explained it a little bit. And I'm going to further explain it a
How is
little
that
bit.
107? Because you
Kaylee,
I swear to God.
basically what you're doing with that is instead of going 23 times 7, then adding it together, we're skipping that all the way to the end by putting the 1 at the front.
See, it says single multiplication.
So what happens is,
Does that make sense?
we get the 0.07, you know where we get the 7%
Right?
equals 0.07, right?
Mm-hmm.
In decimal form. And so what we have is our total amount is going to be 23 plus 23 times 0.07, right?
Okay,
And
makes sense.
And between these two numbers, is there a common factor between them?
23.
23. So it's going to be 23 times 1 plus 0.07. And so now when you what it's going to be equal to what Will told us, right? And so that's how you do it, and this is really necessary for where we're going in class here with the exponential functions, okay? So now I want to call on somebody for number,
Wait, go back. I didn't get the answer.
I want to call on somebody for number 4.
We're not gonna write the answer down?
The answer here is right here.
Show how to. It doesn't answer the answer.
Okay, show how to, yeah. Okay, good. Let's go ahead to number 4. And let's choose, we got 4 people left.
It's gonna be,
Kayla,
Number 4,
or 4.
I'll do it for you.
51.9792.
We're not giving the answer, we're showing like the equation that we have to use.
I don't know.
I'll do it for her.
I got you, it's,
52 times 1.04.
no,
No, that'd be added.
It'd be
Yeah,
52
divide.
times 0.96.
That's what I said.
Where did you get 9.6?
Oh, I see what he's doing.
It's you're taking it from 100. So 52 is 100%.
I just
Right.
like doing it.
You don't?
You're
How did you do
taking
this?
the 4% off,
I just
that's
times-
100%.
I just get the 4% and I minus the 4% from it.
Oh, okay, so you took 52 minus 0.04 times 52, right?
Yeah,
Yeah, you can do that. But
it's just
one,
simpler.
but one reason we're doing this is we're trying to
Because of the.
we're trying to diagnose what exponential functions look like. And so it's important to what we're doing now to understand how to put these, because then you'll be able to recognize.
Can you explain what you're doing again?
Okay, yeah, I'll explain.
In a different way?
What happens is you're going to decrease by 4%. So you have 52 minus 4% of 52, right? That's just like a discount at a store, right? You go ahead and the store offers a 10% discount on their price. You want to buy a pair of shoes for $90 and there's a 10% discount. Well, you can subtract 10%, which is 0.1, times $90, right? And if you wrote this as a single equation, you would have 90 minus, you would factor out a 90. 90 is a common factor to this. So here's 90 times 1, right? Minus 0.1. And so that's going to be equal 90 times 0.9. And in this case, you're going to have $9, you get $81 is what it amounts to, right? That's a 10%, yes?
Nothing. I'm just using my calculator.
All right. Okay, good. All right, I see what you're saying. I hear you, I hear what you're saying. Okay, does that make sense? Kaylee, you okay on that now?
Not really.
Not really? Well, we're going to blast through this and you're going to see how. Okay, let's go to number 5. In exercise 5 and 6, solve the equation algebraically. And so, do you want me to work that out, or?
Yeah.
Super difficult.
Why did you just say that?
And so we get b squared is equal to 160 divided by 40, which is 4. And what next?
So,
Square root, right? So B is equal to, is that it? That is not it. What does it come on, guys, please?
Plus or minus 2.
Plus or minus 2. And the key thing being is if you have an even numbered exponent,
Right?
in this case 2, you can end up with a plus or minus type of a solution. All right? What about an odd numbered exponent? Will you have plus or minus? No. So what I want to do is I want to choose somebody for number 6 right here. And there's not a whole lot left here.
No, I was gonna say.
I'm always left to the last 2.
Okay, Carmen? Carmen, you still working on it, Carmen?
I wasn't raised. I'm raised. Wouldn't it be
Mr. G, you can look at this real quick.
Okay, so,
Here, no, it's all right, I'll wait. Is
no, it's fine. Does me good here, I'll tell you.
that right?
Yeah, but it could be simplified more, I
Do you want me to go
think.
ahead and simplify the bottom, because there's nothing that,
Yeah,
there's nothing that can,
it gets more simplified than that is what it amounts to.
okay.
Carmen, you got it yet?
what did you get?
What'd you get, Carmen? Okay, Carmen got, what, B is equal to plus or minus 1/3?
That's what I got.
It's not what I got. I got B is equal to 1/3.
What's the difference?
Oh, because it's an odd function, so.
Yeah.
It's a cube, so it doesn't matter.
And how'd you do that, Carmen, with your calculator? Yeah, let me show you without a calculator, kind of. Because this is one that you could conceivably maybe do without a calculator. So if you divide by 243,
Oh, yeah, you can just, math.
so we get B cubed is equal to 9 over 243. And what's 9 over 243?
1/3.
Well, it's 1/27. So now if you take the cube root of both sides, right?
You get 1/3.
And so you have cube root of 1 is 1, cube root of 27 is third. So that's going to be our answer there, right? All right, thank you, Carmen.
Hey, I'm doing my work. It's me. Back in 2015.
I thought it was funny. We're at the football game the other night, and this one lady says, "What is your name and what is your age?" Remember that? What is your age? What is your name and how old are you?
Oh, yeah.
Yeah. I thought that was
Miss Jordan.
Jordan.
I said, my name is Kelly Choate. I'm 16 and I live by you.
Oh,
I live down your road.
all right.
She's my neighbor. So.
Okay. All right, next one, I'm going to choose somebody for this one. We know who,
You just leave it in a radical.
Ew. Look.
will.
That should be.
No, what I want you to do is I want you to go ahead and do it and decimalize it to like 3 or 4 decimal places.
Okay.
I still
Yeah.
have it, double check.
I got
This.
equals 1.01159.
Oh my gosh, wait. My teeth are so bad.
So that'd be to several decimal places. I gotta tell you something that's really something worth noticing is typically when we do these types of problems, 3 decimal places is kind of a standard, except in a situation like this, this is gonna be, you're gonna get a very accurate answer with this, but sometimes if we use like 1.012, this power of 6 is going to make the answer less accurate as time goes on. It's like the errors multiply. So if we take 782 times 1.02 to the 6th power to check our work, right? 782 times 1 point, what was that? Forgot already. 1.02, we'll say, 012. 1.012 is what I meant to put down. 0.012 to the power of 6th. Then we get this, which is 840. Yeah, so it's 2 off. Whereas this one here, 1.0059, you're going to see how much more accurate that is.
How do you get the?
Point
Yes.
0.159.
So what you do is you divide by the 72. And so you get this.
Okay, so on this one here,
That fraction.
we got 2 off. On this one here, with going to this many decimal places out, we got 2/100ths off.
Yep.
And so it's like a huge amount of accuracy difference. It's because the 6th power really magnifies the errors. That's what happens. Okay, thank you for that. And does everybody know how to do that 6th root in the calculator? Anybody not know that?
Isn't it math?
Yeah, math 5. Go to math 5,
I
okay?
just put the fraction.
Well, so you did the fractional root, the 1/6.
Yeah, that's what I did.
Yeah, so Will did this to the power of 1/6, which if you know how to do that, which is good. That's a rational. Yeah, I'll give you credit for that, Will. All right, great. Now this one here, this is going to be Angel, right? Angel? All right, Angel.
What about me?
Oh, I didn't get you. Are you not on the list?
It was not on the wheel.
You weren't on the wheel? Okay. Well, I got to put you back there. I got to put you back there, Adam. In fact, Adam, I got you tapped down for number 9. Then I'll fix the wheel too. All right, Angel, what'd you get?
1.411467735.
1 point.
411467735.
Now, with this level of accuracy, you're going to get like, it'll be just like thousands off, if anything. It'll probably give you exactly 521, doesn't it? When you put that together with the calculator, don't you? Yeah. Okay. So that is that one. Okay. Adam. You have B is equal to.
Uh, 1.648473501.
1.64.
84.
Okay.
7
7.
3 5.
So we'll just leave it there. Anything else? Something else,
Yeah.
Plus minus.
I didn't
Yeah,
get
plus or
that.
minus.
plus or minus.
Yeah, I didn't get that.
Yeah.
You didn't get that?
066. Or 0.6.
0.606621823.
Yeah, it should be 6066.
Shoot, what am I at?
It's just
No one.
point,
It's
Point.
just 0.6.
.6066.
606621822.
Okay,
1, 2, 1.
fourth at 91 over 670.
Huh? Because, oh yeah, number 7 would be plus or minus, right? Because it's to the 6th, that's even.
Oh, that's where I messed up. I thought, yeah. 6791.
So that's it there. Okay, Adam, to redeem yourself, I want you to do number 10. So Adam will get redemption from number 10.
Can you go back to number 7 real quick?
I don't know where I messed up.
No, number 7.
Oh, number 7, excuse me. Oops.
For our answer, it's supposed to be plus or minus, because it's to the 6th.
Yeah, it should be plus or minus.
We didn't have to.
That's gonna be plus or minus, yeah.
Don't touch my shoes. Don't touch my shoes. Don't touch my shoes. Don't touch. Touch. Shoe.
I'm not touching it.
Don't touch my shoes.
What is that?
Don't do it. She dare do it. Wait, oh, wait, she dare do it.
Wait, no. 1 second.
Y'all can't impersonate me. Y'all are not that good.
yeah, we are that good.
No, you're not.
You're not.
You're not. It will, he sounds gay.
Just like you did, baby.
Whenever he does it like that.
Yeah.
But am I wrong?
But am I wrong? Am I wrong?
Wait, Gordon, what was it that you said earlier?
Wait, yeah.
All right,
Might have messed up.
Tell us.
Check.
Tell us. Why don't you just tell us? Just tell us. Just say it out loud.
I know I'm gonna get point something because
Yeah.
it's gonna be less than 1.
Eight, eight,
Shut
nine,
up.
6.
8896. Any plus or minus for this one?
No.
Vincent.
Okay, yeah. So B is going to be equal to the 7th root of 56 over 127. Okay, which is going to be this right here. Okay, we're going to start on another exercise set today too,
Mr. G,
which is this one right here. We're going to, it won't be very long.
you say that, but then we're all not gonna finish it.
Please.
Oh, no, we're not going to finish it. We are going to finish it. We're just going to do the first couple problems on this one.
Couple means 2, right?
Couple means 2, yes.
Still doesn't know the full con. No, that's what I was calling you.
Yeah, we're blasting through this thing.
Yeah.
What are you doing another paper?
We're going to start this one. We're going to start.
Well, you're being, like, just.
And one reason I want to get started on this today is because it ties in
Tell us, Will.
pretty tightly with the exercise we just last year.
No, that's fun.
It's not gonna work.
Okay.
Your phone will work there.
So,
And your phone. In your jacket pocket. And your left-hand jacket pocket. That is your button.
Okay,
Left-handed jacket pocket on the left side of your, on the other side. Outside,
okay,
left pocket. Of your leg.
okay, class. I'm going to introduce you to another type of exponential function. Now, in this, the one that we saw earlier was y equals a times b to the power of x, right? Well, what we're going to do is we're going to use the same type of format here, but it's going to be, what happens is this number here, in the language of this function here, what is 3.5 going to be?
Your initial
Initial value.
value.
And this one right here, 1.09 is what?
Is
our base.
Base.
Now what happens is, in exponential growth or decay function, and this is the one that might be the most popular type of real-world use equation in the world that we have, because percentages are used a lot, right? For population growth,
Yep.
for population decline,
Each population.
for money growth,
Yep.
and then
Interest.
interest. Also in exponential growth by cell division in biology, right? Exponential decay, which we talked about, half-life, right? Half-life formula. That's an exponential decay function. So what happens is that the basic format is this. You have P of t equals initial value a, and in the place of base, we put this, 1 plus r to the power of t. And so p can be used for population. So the population with respect to time is equal to the starting population times 1 plus r.
Which is the rate.
And so 1 plus r is equal to b, which is our base. And so in analyzing what's happening here, what is our base in this equation here?
It's 9%. Growth of 9%.
Okay, you're going too far ahead of me, Will. What is this number here is what I was.
1.09.
1.09. So Will was really giving you, so 1.09 is equal to 1 plus our r, right?
Yep.
And so how do you solve for r?
You just take out the 1.
So you have 0.09 is equal to r. Now it's asking, is this an exponential growth or decay function, and what is that constant rate or decay?
Growth since it's over 1.
Okay, this is it. Since r is greater than 1, or excuse me, since base is greater than 1. Let me write two of them. Since base is greater than 1 and r is greater than 0, growth. And what is the percentage growth rate here?
9%.
9%
Plus 9%.
growth rate. Okay? So that is that one. And what I want to do is, I want to go ahead to do just problem 2 today, and I'll choose somebody to do problem 2.
Alright, so
Okay.
just that same thing.
Same type of thing. I want to see here, well, we're sort of here open. Kate, are you volunteering?
What happens if you spin?
I want to do it
I'll do
too.
it. Fine, just spin the wheel. Just spin the
I'll do
wheel.
it.
Yeah, spin the wheel.
I'll do it. Just spin the wheel.
Spin the
I'll do
wheel.
it.
Just spin the wheel like it is.
I'll do it.
Do it. No.
I'll do it.
No.
I'll still do it.
My name's
Yeah.
Mel.
Stop talking.
want to do it.
Nobody asked what you wanted to do.
Hey, Will,
And I'm going to go ahead and fix this one more here.
Yeah.
Maybe we should just get rid of Adam in general. Take him out
Yeah.
of class.
Okay, so that's gonna be 6. All right, so now we have everybody, right? Okay, let the games begin.
For one step to the wheel of fortune. Adam Ball.
Oh,
One,
yeah.
I'll ask you one to do it.
I wanted to do it.
Put his
Somebody
name.
asked if you want it, Kaylee.
All right, so what do you got, Adam?
It is a growth.
So growth. And then percentage rate of growth or decay? Or growth?
1.8%.
1.8%. Everybody see that? You take this 0.018, multiply by 100, that'll be it. So I just want to leave it there today, and so tomorrow we're going to work on more of those, and so that'll be